Hello and welcome to Math 95 Online. This video is section 7.5 from CGCC's Math 95 course titled Equations Involve Radical Expressions. So in this lesson we're going to learn how to solve equations that have radical signs in them. We'll start off with a relatively simple example. The square root of 2x minus 1 equals 3. And you'll see that you use the same strategy in all of the radical equations that we're going to be seeing. Our first step, which is already done for us in this equation, but the first step is to isolate the radical. So get the radical by itself. If you remember back when we were solving absolute value equations, we did the same thing. So here we want to isolate this radical, which is already done for us. And then the second thing that we'll do is to get rid of the radical. In this case, it's a square root. We're going to square both sides. If it was a cube root, we would cube both sides. Whatever we need to do to undo the radical. We could just write undo the radical. And then one thing we need to make sure to do with these, especially if we have a square root or a radical with an even index, like square root, fourth root, sixth root, we always have to check our solutions. Always check solutions, and I'll explain more about this as we go along. But what happens is that if you, for example, with the square root, you square both sides, what you can do is introduce what we call extraneous solutions, which means that they're solutions that are somewhat like posers, I like to say, or they're acting as solutions, but then they don't really work out. There's a negative issue, because when you square both sides, it takes, and whether it's negative or positive to begin with, it becomes positive. So that's where you can introduce these excuse me, extraneous solutions. Okay, so first step here are radicals already isolated. So then we're going to get rid of this radical. We're just going to square both sides. So when you square a square root, you just get the radicand, or what's underneath. And then you just solve like normal from here. So add 1 to each side. 2x is 10. Divide by 2. X equals 5. And then what we need to do is check and make sure that this solution is valid. So if we plug 5 back into the original, and we want to know if this is true. So 2 times 5 is 10, 10 minus 1 is 9, and the square root of 9 is 3. So our answer is x equals 5. Okay, another example. Square root 4 minus x plus 5 equals 8. Okay, so here the radical is not isolated. So that's what we need to do first. We need to subtract 5 from both sides in order to get the radical by itself. And now we'll undo the square root by squaring both sides. So we have 4 minus x equals 9. And then solve for x. So we can subtract 4. Negative x is 5. Divide by negative 1. We have x equals negative 5. And then if we check to make sure that that is correct, we have the square root of 4 minus negative 5. That's the square root, then 2 negatives is positive, so square root of 9, which is 3. Okay, moving on to a little bit more difficult problems. Let's see, we have the square root of 3x plus 3 equaling 2x minus 1. Now here, our radical is already isolated, which is good, but what we have different in this problem, you can see we have a difference over here. So that when we go to get rid of the radical and we square both sides, we have to square this entire side. Now, a very, very common mistake is to just square each of these terms, but that's not, that's highly illegal. It's not a true statement that you can just maintain equality by squaring each term. So what we have to do to this guy over here is we have to FOIL it. It means when you square something, it means it's the base times itself. So this is very important. So when we square this guy out, we have to FOIL, right? So we have 4x squared minus 2x plus 1, and 3x plus 3. So 3x plus 3 equals 4x squared, combine like terms. And now since we have x squareds and x to the first power terms, we're going to have to get everything on one side set equal to 0. Since my leading term is positive on this side, I'm going to move this stuff over here because it's much easier to factor when your leading coefficient's positive. Okay. It's a little bit messy. Okay. Now, we want to look and see if we can factor out a great X's common factor. It'd be nice if this 4 wasn't there, but there's nothing in common in these three terms, so we try to factor. And the way I think about this one is I'm trying to figure out how I'm going to get this minus 7. And the only way I can get negative 2 is a negative 2 and a positive 1, or a positive 2 and a negative 1. So there's not that many choices there, so I'm going to start with that one. And now, the only way to get, the ways I can get 4x squared are 2x and 2x, or 4x and x. So I notice that if I multiply 4x by negative 2, then I'm going to get negative 8x. Plus a x would be negative 7x, so I'm going to try that. So the 4x has to go here if it's going to multiply by the negative 2, and my 1x will go here. And then I should FOIL that out just to make sure that it works. I get 4x squared plus x minus 8x minus 2, which does give us 4x squared minus 7x minus 2, which is what we want. So we have it factored correctly. Now, our last step is to use the zero product principle. So we have it factored. That means x minus 2 is 0, or 4x plus 1 is 0, which means x is 2, or x is negative 1/4 by subtracting the 1 and then dividing by 4. Okay, now don't be tempted to stop here. We have to make sure that we check our answers. So if we write, I'll write again our original problem, and we can check our answers. Our original problem was the square root of 3x plus 3 equals 2x minus 1. So if we plug 2 in, the square root of 3 times 2 plus 3, does that equal 2 times 2 minus 1? So here we have 6 plus 3 is 9, square root of 9 is 3, and 2 times 2 is 4, minus 1 is 3. So that one works. So that's okay. Now we need to do negative 1/4. So we have 3 times negative 1/4 plus 3 equals 2 times negative 1/4 minus 1? This is the question. Okay, so let's do this right side first. 2 times negative 1/4, that's negative a half. Negative a half minus 1, that's negative 3/2. Well, is there any way that a square root of something can be negative? No, there isn't. So, it's not true, which means that this cannot be a solution. So it's just x equals 2. If we were to finish this out over here, we'd have negative 3/4 plus 3 over 1. Need to multiply the top and bottom by 4. So you'd have the square root of, that's 12 minus 3 is 9/4, which is 3/2. And 3/2 does not equal negative 3/2. That's where we run into the problem. So you can see by squaring both sides, if you square each of these, then it is equal. But that's where we get false or extraneous solutions. Okay, good job. Moving on to the last and possibly most difficult type of equation involving square roots is this guy. Square root of 2x minus 1 equaling the square root of x plus 1. See, in this case, we cannot isolate the radical because the radical's in 2 different spots, and they're not like radicals, so we cannot combine them. So what we're going to end up having to do is square both sides twice. So we just do it straight from the beginning. We're going to square that side, square that side. And when we square the left, we have a difference, so we're going to have to FOIL it. And here we have x plus 1. So when we FOIL this, root 2x times root 2x, that is just 2x. Do you recall that root 2x times root 2x, that's going to give you, we can multiply the underneath, 2x squared, which then the square root and the square cancel out, and you just get 2x. And then root 2x times negative 1 is negative root 2x. And we multiply here, we get the same thing. Negative 1 times negative 1 is positive 1. Okay. And then if we combine like terms, these are like radicals. We have negative 1 minus 1, so we have negative 2 root 2x. Okay, and now we can isolate this radical because there's just one of them. So now we want to get this guy by itself. So we'll subtract the 2x, subtract the 1, and we have we have negative 2 root 2x equaling negative x. X minus 2x is negative x. 1 minus 1 is 0. Then we can divide by negative 2. So now those cancel out. And you have root 2x equals negative divided by negative is positive x over 2. And now we're ready to get rid of the radical by squaring both sides. So you have 2x equals x over 2 squared. You square the top, square the bottom. So we have x squared over 4. And now, since we have an x squared term and an x term, we are going to probably have to end up factoring. So we can get rid of the fraction if we want, which would be kind of nice. Multiply both sides by 4. So we have 8x equals x squared. Then if we get one side equal to 0, because that's how we solve quadratics until next week when we do chapter 8, We have 0 equals x squared minus 8x. And we have x as a common term. So we can factor out an x. Then x equals 0. X minus 8 equals 0. Or x equals 8. So our two solutions, our two possible solutions, are x equals 0 and x equals 8. Then we have to check them. So if we look back at what the original was, square root 2x minus 1, square root x plus 1. If we plug in 0, 0 times 2 is 0, so then we get negative 1, because the square root of 0 is 0. So does negative 1 equal the square root of 1? No. So that's not a solution. If we plug in 8, we have the square root of 16 minus 1. Does that equal the square root of 9? Square root of 16 is 4. 4 minus 1 is 3. Square root of 9 is 3. So that works. So x equals 8 is our solution. Alright, very good. So that's it for solving square roots. Now at the end of your assignment, there's a question involving a cube root. So I thought we'd take a look. These are actually much easier than maybe they look. So how would you undo a cube root, right? A square root we undo by squaring both sides. So a cube root we undo by cubing both sides. Okay, so then we have 4x minus 7 equals 4 cubed is 64, and then you just solve it. So 4x equals 71, divide by 4. X is, that isn't nice, so we'll just leave it as 71/4. Now that looks kind of like an ugly solution to check, but the good news is that we don't have to check it because A, we know that we did our math right. We don't always know that, but I'm confident about that. That would be the only case of why you would need to check your answers if you've made a mistake. Because when we have the cube root and we're cubing, the signs still stay the same. If you were to have a negative number and you cube it, it remains negative. A positive number and you cube it, it remains positive. You don't have the switching from negative to positive, which gives us extraneous solutions. So if you're doing anything with an odd index, solving it, so you're going to take it to an odd power, it's not completely necessary that you check your answer. Although whenever you're taking an exam, you should always check your answer, because sometimes we make silly mistakes. Okay, the last part of this section is the distance formula. And the distance formula, they derive it in your textbook, I believe, and I'm not going to spend the time on this video because your attention span's probably already about done. Looks like we're about 18.5 minutes already, so I don't want to lose your attention span any more than I already have. So I'm just going to give it to you. It's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And I'm just going to talk to you a little bit about what this is. This has a look a lot like a squared plus b squared equals c squared, which is the Pythagorean theorem, if I can spell it correctly. Theorem. So the way that you derive or come up with a distance formula is using this guy, and then we just solve for the hypotenuse, the c. Because what you're trying to do is you're trying to find the distance between 2 points, and we call these points x1, y1, and x2, y2. So that's where these names come from. It's just the first point and the second point. And then we're trying to find this distance between them. And what we can do is we can make a right triangle out of it. Okay, so that's a right triangle. And this distance here is the distance between the x values, which is x2 minus x1. And this distance here is the distance between the y values, or y2 minus y1. So then what we have is this squared plus this squared equals this distance squared. And then we just take the square root of both sides to figure out the distance. So that's where it comes from. Sort of derived it for you. But what I want to do is just show you how it works in an example. Oh, I also wanted to mention, some students will say, can't we simplify this so that the square root cancels out the squares? And you can't because of the plus right there, right? We cannot distribute the square root amongst addition. So it cannot be simplified any more than it is. And if you try to, then you've broken some law. Anyway, okay, so here is an example. So find the distance between the points -2, 3 and 1, -4. So that's what the question would look like. Find the distance between these 2 points. They could trick you a little bit and say this point and the origin, which gives you 0, 0. Or you could say between this point and the y-intercept of this other line. So sometimes you have to read between the lines to figure out what those 2 points are, but they have to give you enough information to have these 2 points. And then we're going to plug it into the distance formula, which we'll write again. Just the more you write it, the more you'll remember it. And then what I often do, just because the most common errors here are just plugging in errors, like a negative error or switching the points or something like that. So I just label these points, x1, y1, x2, y2, and then that helps minimize mistakes. You could have labeled this point x2, y2 and this one x1, y1, as long as you don't have x1, y2, right? Mixing them up like that. So these guys have to stick together. So we have d equals x2, which is 1, minus x1, which is -2, squared, plus y2, which is -4, minus y1, which is 3, squared. Then order of operations, we have to do the parentheses first. So minus and negative is plus, so that gives us 3 squared plus, now we have -7 squared, which is 9 plus 49, which is the square root of 58. And we'll just leave it like that. Duh. Okay, that is the end of 7.5. Enjoy your homework.